Long has man impacted the earth, but a recent period of acceleration in technology, productivity, and in turn population growth has thrusted us into a human planet, one which the systems that sustain life are modified by humans than by any other driving force. The Anthropocene, a new geological epoch. So how did we get here?
Behind me are hills and peaks formed nearly 10,000 years ago by the retreating of the last ice age. Since then, about 10,000 years of relatively stable climatic conditions that geologists call the Holocene. Within that time, man has created lakes, changed the direction of rivers, and even the direction of our climate. Carbon dioxide has oscillated wildly over the 5 billion years of the Earth's history. On one occasion, evolution of photosynthesis was a natural cause by life. But it's not all about carbon. Agreements and goals and objectives set by nations are focused purely on carbon and sticking to 1.5 degrees warming, and that is the limit. Some have said, in fact, we're so focused on carbon we can't see the wood for the trees, and have suggested we introduce something called planetary boundaries, which is where we view the whole Earth system as one thing, and all the different inputs and all the different systems within that, so climate, weather, nutrients, cycling, the ecosystems and the plants and the birds and everything, put it all together. What's going to happen if the limits are exceeded in one area? There's a lot of unknowns here. So, for example, we don't really know what's going to happen if we use up all our phosphorus, or if all the moisture in one part of the world disappears. What's going to happen to overall climate? There's tipping points, essentially. There's points where, because there is so many unknowns, that if we do progress to a certain point, then what will be the drastic outcome? We don't really know. There are certain things that will need to be addressed. Our current usage of consumption, our current treatment of terrestrial ecosystems and marine ecosystems. And so I'm going to be using this time within this video to cover some topics and to try and address some of these issues and look at if there are some solutions. In England, the Industrial Revolution brought large houses of labour where raw material shipped from all over the world was aided by the veins of the canals, and they got modified into products. As the pockets of the mill owners grew heavier, so did the lungs of the workers. Black smog was trapped in the ever-increasingly populous urban centres. Now, we've exported most of this labour, and with it, our control of environmental ramifications. And with each technological improvement, new distorted pollutants have found their way into our Earth's system. Back then, mill dried cotton into threads. Now my waterproof jacket is treated with polyfluoroalkyl substance, or PFAS, and it's here to stay, whether that is ingested by myself or washed into the soil or rivers. When a product is perceived as obsolete by the consumer, it's thrown away and forgotten. Yet we are now living in a period where waste is profitable. There's a rush for gold, copper, tungsten and silver, along with many rare metals you've likely never ever heard of, and they're stored in the very products that are discarded. However, due to these elements being in very small quantities with an alloy stroke combination of other metals, currently they're essentially trapped. So, is recycling the answer?
International agreements state so. However, in practice, the majority of e-waste is shipped to Asia, despite the agreement of nations. That's the UN Basel Convention. They all agreed to that. Not to ship any toxic waste or any harmful waste. But yeah, currently technology for recycling precious metals is lagging way far behind the rate at which they are being extracted. It is unsustainable. So curbing temperature increases with green technologies and ridding ourselves of our reliance on dirty fossil fuels is heavily coveted. It's pointed out by Guillaume Patron in the Rare Metals Wars, when there's an unregulated and a nice hefty tax relief for these nice new shiny bits of technology, it's not really a surprise that there's little admittance of how the manufacturing of these technological solution is unsustainable, deleterious to our environment and human welfare.
And so the materials required for renewable energies, where do they actually come from? Well, they come from underground. They need to be mined. One paper actually pointed out that the mining for renewable energies is threatening biodiversity because they're taking place of natural beauty. Well, if they're underground, what's the issue here then? What's the problem because they're underground? Well, actually, most mines are actually open, and water flows through them, and waste is just dumped next to them. And it takes a tremendous amount of energy to get this rock out of the ground in the first place, a lot of which is actually fossil fuel energy that's being used currently. And then it's a lot of energy to refine that rock into the metals that are actually useful. And these metals just aren't as accessible as just plucking a bauble off of a Christmas tree. We actually need to apply a tremendous amount of force, heat, chemicals, and a lot of water needs to be pushed through as well to get these materials out of the rock. When we do put all this force and water, it also mobilizes and displaces toxic, unwanted chemicals and metals that we don't want, like molybdenum and uranium. That end up in the soil and as well as the groundwater.
Soil is not merely dirt that gets on your clothes. If you trace back where it actually came from, it comes from the fusion of stars. All those elements that are in soil came from the fusion of the combination of all the things in the universe. It's pretty cool. But we heavily mistreat soil through agricultural practices, through deposition of nitrogen, compaction. We tread on it just beneath our feet as though it's nothing. Poor soil, hey? It's not great. Not only is soil cosmically cool, it provides us with a lot of things we'd be pretty stuffed without, such as food, water purification, carbon storage, amongst a multitude of other things that you can't think of. Without soil, there would be this stuff behind me. It wouldn't be there. Where would it be without soil? Before I forget and keep going on and glutting over how great soil is, what actually is it? Well, by volume, 25% typically is empty air, nothing. It's just, there's nothing there. It's just oxygen. By mass, so by weight, you're looking at about, let me just check, 95% of it's finely ground rock, and other bits of rock and stuff. Then you got 5% of it's about organic matter, and within that organic matter, obviously you got your carbon, that stuff that used to be living but now is dead. And then there's a very small percentage, about 0.5 to 1% of the mass of soil is microbes, so things that aren't dead, that are alive. And those small microbes, they play a crucial role. They are the ones that are turning that organic matter, or that just dead organic matter, back into more soil. But the real creator of soil is time. Long, drawn out geological processes. As I mentioned when I was up on a hill over there, there's the constriction of glaciers and just general weathering of a long period of time creates soil. But here I'm referring to the qualities of healthy soil, and the creation of healthy soil, as I said, takes time. So we don't want to be losing it, and we're losing it at an alarming rate. When organic matter and microbes are stripped out the soil, and when we compact the soil and prevent any oxygen going in there, you get rubbish soil that can't really grow anything, and the whole ecosystem suffers, and the niches that are available to be sustained by that soil are drastically reduced. So how can we improve soil? How can we make sure that our soil is healthy? Well, first thing, we can cover it up. We can grow things on it. If we leave soil bare, it means it's exposed to be weathered and moved around and pushed down into the river. Without those things growing on it, there's not the associations with the microbes in the soil. The microbes in the soil rely heavily on the plants to be there in the first place. You've got rhizobacteria, you've got mycofungi that's growing everywhere, that's communicating between each plants about where all the nutrients are. That's a very generic cover of soil microbia, but if you want to learn more, I'd say start digging. And one major thing that benefits soil is having a diverse range of things that are surrounding it. Because with that, you can have a diverse range of inputs going into the soil, not just rain and nothing else.
What are we doing to our water? Well, some things just out of our control. The chemical, ecological and physical properties of this little river stream behind me, well, that's mostly determined by the underlying geology, the topography that's surrounding it, and this little stream is the River Dove. This stream then goes into the River Dearne, which then goes into the River Don, which goes into Tidal Ouse, which then goes into the estuary, the Humber estuary, not just any old estuary. And along the stretch from here to the North Sea is facing many issues. This river, unlike many, it's not very good. About 14% in England of all rivers fail to meet good ecological quality, and absolutely none of them meet good chemical quality, which is pretty rubbish really. And I know for a fact this stream here is not very good. Downstream you've got a pheasant farm with all that pheasant poo going in, you've got lots of farmland just spreading, diffused pollution all over the stretch. And none of this is going to get any better under climate change either. With warmer temperatures, elevated temperatures, the chemical reactions that have been, all the different pollutants, all the chemical reactions that occur are going to be sped up. If you heat up a bottle, it gets all the chemical reactions get faster, essentially. As well as that, oxygen. Hot water can't hold oxygen as well as cooler water either. So any fish in there's going to be less oxygen for them. They'll die. Rainfall patterns are going to change under climate change, meaning that in summer months this stream will be drier, and any pollution that is going into here is going to be in a higher concentration as well.
So what is polluting our rivers, and where does it come from? Well, it can either be diffuse, spread over large areas, such as fertilizer being spread over many fields, or it can come from a single point, like an outfall from a wastewater treatment works or an industrial site. I mean, unlike swearing at your train conductor, there isn't a zero tolerance approach to water pollution. Instead, recommendations of standards of acceptable pollution levels are in place. Many come from OG Water Framework Directive, bits of stuff that's been put in by the European Union, but the United Kingdom is now retrofitted. And in these Water Framework Directive recommendations, the main steer and this is how you should be doing things is
do it at a catchment scale. Well, what is a catchment? Well, if the rain falls over here, this side of the mountains, it's in this catchment. If it falls over here on the other side of these mountains, it's in another one. It's based on the topography, the geography of where the ground moves the water.
But pollution isn't the only issue facing rivers. Our industrial past has left scars on the meanders and the natural flows of our rivers. The mills, they've put weirs in place to harness the energy of the fast flowing river. Behind me looks like it could be a natural weir, who knows. However, what it's essentially doing is stopping any fish coming upstream. It's not very good really, is it? And the straightening of rivers. Here it's nice and meander, it's lots of twists and turns. If I was to go down into Leeds city centre or something like that, there's lots of straight edges. You can't, natural bends aren't there. And what that does, increases the velocity of the river going downstream. It causes that there's not any nice embankments for any habitat there. Essentially, you get a very sterile and not very good river.
When the river meets the sea, biogeochemical processes differ, and so do the human impacts. And the ocean's huge. It makes about 71% of the Earth's surface, so it's important that we do look at it. I know I've left this till last, but anyway. We dump in the sea not only our waste, but also carbon. Just about under a third of all the carbon that we do put into the atmosphere is then taken back up by our ocean. And this is actually making the ocean more acidic because of this chemical reaction here on screen, and it creates carbonic acid. And the more hydrogen ions mean that calcifying shell creatures, they're going to struggle to form their protective shells, which is going to have massive knock-on effects across trophic systems and also known as food webs. But we also take from our oceans. As population growth is going to increase, so will the demand for protein, and it's going to pose a risk to fish stocks. So there needs to be an equilibrium between the demand and the resource, the fish, that are actually available. And the important thing to remember here is that when we do take, say, an Atlantic cod out of the Atlantic Sea, it's not a self-contained action, but one that requires plastic nets and lines to be spread, and sometimes those lines and nets are left there. And out of all the plastic pollution in the ocean, about 10 to 20% is actually due to industrial fishing. Industrial fishing tackle. And caught in these nets is non-target species or bycatch. So fish that aren't the small little tiddlers, to dolphins, to birds, even turtles. So I'm going to wrap this up now by talking about something called the tragedy of commons, which applies very well to the ocean, which is an open resource that is being depleted by competing self-interests. And when we try and apply the tragedy of commons to land, it becomes much more abstract, as private ownership has actually sort of shifted the perception of how we manage our Earth. How can it be ours when it's fenced, netted, and mined by unknown entities? So, what's the solution? We can legislate, restrict, and make them pay, surely. Well, how effective is that? Well, that's a topic in and of itself, and we're running out of time. Goodbye.